Okay, so our next speaker is Athanassios Liakopoulos, who works for the Greek Research and Technology Network. He's responsible for coordinating activities regarding networking and computing infrastructure, and in a sign of monumental courage and determination, they're going to do a demo. Right, so we get to see running code.
Thank you very much. Hello, everybody. Today, I'm not going to talk about IPv6. I'm not going to talk about sensors, sorry. I'm going to address some of the challenges that we face in our network from a more theoretical perspective, okay? And after that, I'll try to come up to the reality. So we are going to have a demonstration and see what can be done based on theoretical concepts and ideas. And at the end, I'll try to combine the theoretical world with the IPv6 world that we are actually investigating today. So this is the presentation outline. I go through quite quickly, so I don't want to mix you here. I start with some theoretical background, okay? Everybody talks about Internet of the Things in the research community. It's whatever we talk about IPv6 when we are talking with technical people or business people. Actually, this environment, this new infrastructure has to include all the devices that we can imagine, even new ones, and of course has to interconnect heterogeneous devices, so it has to be inclusive and diverse. Of course, it has to be reliable, it has to be resilient. We all understand the reasons for that. We need an infrastructure that has to be scalable, sustainable. We understand that we should be able to handle all the challenges that exist within the network and try to improve it. Of course, we need to have a safe infrastructure and secure regarding the data that we exchange over the network, regarding the devices that we connect, the infrastructure per se. Okay? And of course, we need this infrastructure to be accessible by everyone, everywhere. Of course, we need to have an open infrastructure that actually allow us to share our information, our ideas, our views with everybody. Our proposal is that Internet of the Things, okay, it can be actually based on four distinct principles. And these are augmented content, which means that we have to make sure that devices really understand the environment and can be able to act to the stimulus of the environment. We also propose to establish a virtual infrastructure that can be really hide some of the dynamicity and the heterogeneity that exist on the physical infrastructure. Another principle that we have to take into consideration is to be able to deploy adaptive services, that they can understand the existing conditions, adapt, and be optimized. And of course, we need to rely on autonomic management, not because we are lazy, not for that, but because the complexity is going to be too much in the future if we don't take these measures now. I'm not going to discuss all the four principles here, so I'm going to concentrate only how we are going to build a virtual infrastructure and how we can use it. What we propose is to combine two different worlds, the IP world and the overlay world. So we create something that really can hide some of the problems or solve some of the problems that we have faced today. We're talking about challenges regarding dynamic topology within the physical infrastructure, unreliable operation between the nodes, between the links. We also trying to address some of the complexities that exist in the network and the service development and provisioning models. We also try to solve problems that exist due to loose control of the devices that are interconnected, because in the future we are not going to control everything. Definitely we need to make sure that we have efficient use of the resources. We have devices that have plenty of CPU power, devices that have plenty of battery, devices that don't have either of them, but we need to have all of them connected, operate as much as possible. And of course, we need to provide some kind of redundancy, so the network and the infrastructure is reliable. So what we propose regarding the virtual infrastructure is that we make the nodes, the devices, to understand their neighbors, try to communicate to each other in a one-hop way, then create a routing protocol that allows them to communicate in a multi-hop way, then create a virtual infrastructure based on peer-to-peer protocols and DHT. On top of this infrastructure, we propose to have a generic application interface that actually hides only the underneath dynamicity, mobility, and all the other stuff that make our life difficult. So we make sure that whoever writes the application, he just cares about how to store and how to retrieve data from the infrastructure. And he doesn't care what happens underneath. On top of this, we always try to have services and management tools that actually exploit context models, information fusion techniques, bio-inspired techniques. These are very critical. One last theoretical part and go to the demonstration. We make sure that we understand that we have to exploit autonomic principles when we design the network, we design the services, or whatever we want to achieve over the network. We're talking about self-configuration. I think everybody understands the term. Self-optimization. We should be able to adjust the parameters of the protocols, of the services, according to the existing infrastructure. We should emphasize that the network can really change rapidly in few seconds in the future. So our protocol should be able to adapt to that. Of course, we need self-healing because we have unreliable operation of the nodes. We need to self-protect the infrastructure and the devices. We explained that. And of course, we have to understand, the device have to understand the environment. I put a picture of a simplified version of control loop defined in a research project. I think it would be nice to have a look and try to identify what are all these elements in this picture. So I'm going to the prototype. We are going to show you that what I explained in a research environment, these research concepts actually can be realized. So what we are going to have as a scenario here is, imagine you being in a conference, you listen to somebody that you don't like him, maybe like me, and you want to have a beer. And what you would like to do? You just create an ad hoc network, okay? And then you start communicating with the other people because a virtual infrastructure has been deployed automatically using your devices, like a device, a mobile, like this one. And then when this infrastructure has been created, then you have a very simple and very thin service that can run on top of it, so you can actually start communicating and exchanging messages. So after a while, you can go for a beer. So my colleague Panos is going to help me with a prototype we are going to show you right now. So what we are going to do is I'm going to connect one laptop with two more other devices that are connected over the wireless. The laptop will be connected with Worldline to the access point, but this can be really a reason to understand that we can connect everything, everywhere, with whatever medium we have available. And what I'm going to do is I create one simple software, and the same software, I'm going to use it in the different devices, and by running that, devices will start communicate to each other, and then they will be able to create a chat room, and we'll start exchanging messages. Just to make sure that Murphy's law is always here. So. Yeah. Okay. Is this one? Sorry for this.